Now this problem is just to find the zeros of the polynomial. So the zeros are where this right here is going to be equal to 0. So the zeros, let's have it, no e. The zeros are going to be -3 and 1. It's just opposite of the, this right here. 1 minus 1 is 0, and -3 plus 3 is 0. The multiplicity of each one is going to be -3. The multiplicity is 2, and here the multiplicity is 1. There's like a 1 right here, right? And that would be it for that problem. Find the zeros of this one, and so on. So we're going to do the same thing here. Zeros, multiplicity. The zeros here are -1, 4, and 1. Okay, the multiplicity is 1. Multiplicity here is 1. The multiplicity here is 2. So the way it works is we care about if this is even or odd. So this is odd. I don't have to write this down, but just to stress the point. Whenever it's odd always goes through the 0. That's supposed to go through that point. Odd would cross the it crosses, and the even just touches it and then bounces back. So this is even and touches and turns around. That's what it says. Touches, and we'll just say touches, this last one, and turns around. So at each intercept, this one crosses at these two and just touches at this one. And that would be our answer. At x equals -1, crosses. At x equals 4, crosses. At x equals 1, it touches. Solve this polynomial inequality by graphing. So this is the polynomial, and we just care, where is it greater than 0? Where is it positive? Well, it's clearly positive from here, and this is strictly, right? So it's going to be an open circle from here to here. This is -1 to 0. It's negative here, and then it's positive again from here to here. It's positive because it's up here. So this is union 2, 4, and that would be it. That's from here to here. From here to here, it's positive. Okay. What is the domain and what is the range? So the domain is usually the question is where can things go wrong? And wherever it goes wrong, you just exclude those points from the real number line. So here, and there's two cases in this class. For rational, when you have fractions, it's division by 0. And when you have roots, you need it to be positive, non-negative actually, so it needs to be greater than 0, greater than or equal to 0 for even roots. What this means is like the square root of x minus 2. This right here would have to be greater than or equal to 0. and you would just solve that. Or if this was a fourth power or something, that's an even root. So here we're dividing, and so the only thing that can go wrong is when this is equal to 0. Well, and this is really easy to solve. You just take the square root of both sides, you get 0. So when x is equal to 4, there's a problem. So therefore the domain is everything but 4. Now, we usually want a number line, so that means is everything but negative 4. Actually, this is negative 4, everything but negative 4. So this would be negative infinity to negative 4 union negative 4 to infinity. Right? Now the range is well, there's two ways to do this. You can graph it, or you can remember, and there's actually another way to solve both of these problems, is we got to think back to our base function here. So our base function is on both of these, actually it's different on both of these. So I overlooked this squared right here. The base function is 1 over x squared. Now, I think the truth is that we're probably not going to remember this for the test. So the way I'm going to do this, I mean, I could give you what it is, the range and everything. For the squared is going to be greater than 0. But let's say you forgot that on the test. You got so much to memorize, you don't remember. So what we're going to do here is we're going to graph this and see what that can tell us. Right? We just completely forgot what the range is. And so we're going to graph. I'm going to make sure everything's reset. Oops. Zoom standard. So here we can see the base function is the square root, and it usually looks like this. You can see here that it's moved over negative 4 and it's not defined at negative 4, so that's the domain. The range here is pretty obvious. It's going to be all positive. Which y values does it take on? Anything from greater than 0 to infinity. It never goes down here. So what I'm going to do is, using the graph, that's how I'm going to answer this question. So the range, this is all still number 29. Range is 0 to infinity. Now this one is the base function is a 1 over x. Now I can remember that 1 over x kind of looks like, this. And then I can think of this as horizontal and vertical transformations. Let's say I forgot all that. This is where our graphing calculator helps us. We graph this, and we get 1. Very important to put parentheses, or it will be wrong because of PEMDAS. It's very important to put the x too. X minus 1, parentheses, and then plus 3. We graph it. Now what we should see is the original function shifted to the right by 1 and then shifted up by 3. And sure enough, we can see that here. This got shifted over by 1, and this is 1, 2, 3. This is the vertical shifting. The range seems to be every number except for 3. There's no way you can get 3 out of here. To get 3 would mean that this is equal to 0, and you can't turn a fraction into 0 like this, unless the top was 0. and the top can never be 0 here. So the domain here is everything but 1. So the domain is everything but 1, which means negative infinity to 1 union 1 to infinity. The range is all y values except for 3, which is negative infinity to 3 union 3 to infinity. And that would be our answer.